about the drill materials. Okay, so drill materials and cutting speed, feed, depth of cut, and list of drilling machine operations. Okay, so what are the operations to be performed on the drilling machines? See here the drill materials. Okay, so the drill materials are made up of high carbon steel or high speed steel, tungsten carbide. Okay, so these are the material which by using which the drills are made. Okay, high carbon steel, that is HCS or HSS or tungsten carbide. Okay, see high carbon steels are used for slow speed drilling operations. Okay, slow speed drilling operations, for that we use high carbon steel. Okay, so high speed steel, that is HSS drills, are used for high cutting speed. Okay, low cutting speed we use high carbon steels, and high cutting speeds we use high speed steel. Okay, they can retain at 600 degrees temperature. Okay, 600 degrees centigrade temperature. See, high speed steel drills are used for tough casting and forgings. Tough casting and forging with good cutting efficiency. The tungsten carbide drills are used for drilling abrasive materials. Okay, tungsten carbide drills are used for drilling abrasive materials. These are the types of materials. Okay, so high speed steel, high carbon steel, and tungsten carbide. Okay, and then we have a few definitions. One is cutting speed. Okay, so the cutting speed of the drill is defined as a peripheral speed of the drill. Okay, it is a peripheral speed of the drill surface which is in contact with the work is called cutting speed. Okay, so it is expressed in meters per minute. So the cutting speed is denoted as pi d n by 1000, that is in meters per minute, where the d is called diameter of drill in mm. So n is the speed of the drill spindle in rpm. So the feed. Okay, so the feed of the drill is the distance that the drill enters the work for each revolution of the drill. Okay, the feed of a drill is the distance that the drill enters the work for each revolution of the drill. Okay, so it is expressed in mm per revolution. Okay, mm per revolution. So that is feed per minute is equal S into n, where S is the feed per revolution and n is the speed of the drill in rpm. Okay, so the feed depends on the following factors. So we have a few factors. The first one is the material being cut. Okay, first one is the material being cut, and second one is the rigidity of the machine, and third one is depth of the hole, and fourth one is type of finish required, and fifth one is power available, and sixth one is range of feed available. Okay, so these are the factors depends on the feed. Okay, so next other definition is depth of cut. So of the diameter of the drill is known as depth of cut. Of the diameter of the drill is known as depth of cut. Okay, depth of cut, it is denoted T is equal to small d by 2, where d is the diameter of the drill. Okay, so these are the few definitions in drilling, that is cutting speed, feed, and depth of cut. And the next other topic is a very important topic, that is drilling machine operations. So by using drilling machine we can perform the various operations. Okay, so what are the operations means? So the first one is drilling and reaming, boring, and counter boring, counter sinking, tapping, spot facing, and as well as trepanning. Okay, so these all are the various drilling operations can be performed by a drilling machine. Okay, we will see one by one. The first one is drilling. So it is a process of making a cylindrical hole by rotating a cutting tool called drill. Okay, so the hole location is marked out. First the hole location is marked out. The accuracy and surface finish is poor. Okay, so it is rough machining operation. Drilling is a rough machining operation. So we can be able to see how the drilling operation is performed on the slide. That is a figure it will be shows, that is the drilling operations. Okay, and then next operation is the reaming. After performing the drilling, so we will go for the reaming operation. So it is a process of making the hole smoothly and accurately to the size by using the reamer. Okay, it is used to make the hole smoothly and as well as accurately. Okay. So to finish the hole to a required size, it should be drilled under the size. Okay, it should be drilled under the size. Then the reamer is used first we will use a drilling operation. That drilling operation may not be produce the accurate one, okay, it may produce under the size, okay. After performing the drilling operation, you can go for the reaming operation. That reaming will be brings to exact size, okay, by removing the small amount of material from the hole, okay. So by using that, it produces a high accuracy, also going to get it, okay. So the reaming operations, the reamer tool is used to perform this reaming operation. And the next operation is the boring operation. So it is a process of enlarging the hole by a single point cutting tool, okay. So the boring operation is used to enlarge the hole, okay. So make the hole to at any size, make the hole to any size with good finish, okay, make the hole to at any size to good finish. The operation can be performed on existing hole, operation can be performed on existing hole, that is a boring tool, okay. And then next counter boring, this operation of enlarging the hole for a part of depth with the tool called counter borer, So the process is often used in order that the head of the bolt or screws can lay flush with the face of the job, okay. So counter boring is a operation of enlarging the hole, for a part of its depth, with a tool called counter borer, okay. So the process is often used in order that the hands of the bolts or screws can lay flush with the face of the job, okay. So this is in figure we will be able to see the counter boring operation. The next one is a counter sinking operation. So it is operation of forming chamfers. It is operation of forming chamfers at the edges, okay, at the edges of the hole with counter sinking tool, okay, with counter sinking tool. The counter sinking tools are made with included angle of either 60 degrees or 90 degrees, okay. So that is a counter sinking operations. And the next one is tapping. This is the most important one. So it is a operation of cutting internal threads. By using a tool called a tap, okay. So it is available in various sizes. So tapping is the operation of producing internal threads, okay. So it can be performed by using a tool called tap, okay. So tap wrench. So here we are able to see how the cutting operation will be taking place, that is the tapping operation. The next one is the spot facing. It is a process of machining the surface around the hole. Okay. The spot facing is required for circular seating bolt head to sit at right angles to the existing holes, okay. Spot facing is required for a circular seatings, okay. So bolt heads to sit at right angle to the existing holes, okay. Then next is spot facing, that what we see in spot facing, in the figure we will see. So here the spot facing tool. Then next one is a trepanning operation. So it's a last operation. So it is the operation of producing the hole by removing metal along the circumference of a hollow cutting tool. It is used for producing the large holes. A few chips are removed and much of the material is saved while the hole is produced. Okay, that is a trepanning operation. So here we will see. So as in today's class we discussed about the drill materials and the drilling operations. Okay, so the various drilling operations are performed by using drilling machines, likely drilling, reaming, boring, counter boring, counter sinking, tapping, spot facing and trepanning operations. Okay, so in the next class we will discuss the new topic. Okay, so thank you.